Well, hello and welcome to this talk on new Java best practices. Happy tagline of Java is evolved and so must we. So I'm Stephen Colebourne, sometimes known as Joda Stephen, or to the Dutch friends around, Yoda Stephen. Familiar for putting java.time into the JDK, also Joda Time, Joda Money, 310 Extra, Java Champion. Just some clarifications at the bottom there. So I don't work for Oracle. Some people sometimes think I do, but I definitely don't work for Oracle. That's what allows me to, on occasion, criticize them or be a friendly critique. And these are my opinions. They're definitely not those of my employer. Cool. So what is a best practice? Well, if you look on Wikipedia or whatever, it'll say something like this. So a method, a technique, something that's generally accepted, and it's superior to the alternatives, so something that actually produces good results. I mean, that kind of makes sense, right? So what are the new Java best practices? Well, whatever I say they are, right? I think it's important to realize that software best practices, this isn't like civil engineering, where people have figured them out over many years, and you could do mathematical calculations, work out what they are. They're often opinion. Hopefully, what I'm doing here is to generally summarizing what the masses' opinion are rather than more what my opinion is, but we'll see. So at this stage, I think most of the Java 8 best practices are probably fairly well known, but some of the Java 9 to 25 features can be a bit more divisive. So, don't just take what I say, make up your own mind. So this is based on a talk I did in 2016, Java 8 best practices. There I had 20 best practices, 3 top tips. So 19 of those I would say, would be considered to be best practice today. There was one which I suggested which didn't get adopted. Most of those, again, pretty accepted. I'm revisiting optional and null today because I still think that's a controversial topic. So what we'll do today is just cover language changes since Java 8. There's not enough time to do all the libraries as well. Revisit optional null and just look at the direction we're going. Now, this isn't an AI talk, but I thought I'd have some fun and generate some AI images, which was relatively good. I quite like that one anyway. So a quick look at the evolution of Java. So this is the timeline of Java, with at the bottom me summarizing it up into sort of 4 periods. So as you can see, the releases, we had initially a set of releases, 1, 2, 3, 4, 5, that came out in relative succession. Then it kind of got a bit less and less with 6 and 7 and 8, and then even 9. And then obviously after 9, everything's picked up again. And if you look underneath, we've got this period. You had the initial growth period, and then some microsystems went out of business, and there wasn't any money to invest in Java. And then Oracle took over, and there was a lot of legacy, a lot of technical debt, a lot of figuring out what we're going to do, how are we going to get out of this. And so that period in the middle, the yellow and the red, is actually remarkably long if you look at the total timeline. So it's only in recent years that we've actually had a big uptake and an uptick in what's been added into Java. So you can kind of see this actually even now. If you look at what's in Java 11, a few things, Java 17, a few more, Java 21, a few more. Java 25, I actually had to shrink the font to get everything in. Because fundamentally, more is being added each time, it feels like. So the first best practice is basically use an appropriate version of Java. It makes sense to keep on moving up. It doesn't make sense to get stuck on 11 or 17 or 21 now. 25 is out. You need to be moving forward. However, I'll give you a hall pass. If you want to stay on Java 8, my gut feeling is Java 8 will be around for a long time. Now, officially, Java 8 is only supported for a certain number of years. But my gut feeling is that as we get closer to that date will slightly move out and slightly move out. I think Java 8 is such solidified in actual enterprise applications that it's probably going to be around for a long time. That's my opinion. So yeah, plan to migrate to a new version as quickly as you can. It definitely does help. And if you haven't heard of Open Rewrite, it is a great tool that will allow you to migrate some of your code forwards between these major versions. So just briefly going back to this, the ones I highlighted in the bright green represent the bigger releases. So if you look at it, when did our best practices change? So they changed at Java 2 when collections and things came out. They changed to Java 5 when we got generics and annotations and enums. They changed to Java 8 when we got lambdas, streams, and so on. Is now a good time to review our best practices? Hopefully at the end of the talk I'll kind of say why I think it probably is. Modules. Okay, so this is actually, if you look at the period after Java 8 up until now, they're probably the biggest change. You know, they're the biggest thing. They had the biggest impact in terms of what the JDK actually is. Ultimately, it's just a grouping of packages and then some extra security features added on top of that. Allow you to declare dependencies, declare services, all this kind of stuff. But what is the best practice around modules? Now, Oracle won't tell you that, right? I mean, personally, I've had nothing but pain from modules. I found releasing an open source library, which is modular, has been incredibly painful. I now feel I have to test whether the module is on the class path or on the module path, because it might do different things. And Maven doesn't provide a great deal of support for running it in both ways, so you have to have complicated Maven setups that allow you to do that. Ultimately, modules are not widely adopted, and I don't think there's really any evidence that that's going to change in the near future. But they are really important for the JDK. Right? They were a tool that was necessary for the JDK to lock itself down so it could evolve further. So the reason why we have 10, 11, 12, all the way up to 25 is because they were actually able to lock the JDK down, and modules were a key part of that. So let's not just dismiss modules as being terrible. And if you have specific use cases which validate them, perhaps if you need to produce packages, there might be use cases for them. But as a general rule, they're not much use, in my opinion, for building applications. And the reason why is at the bottom there, because they don't really enforce module boundaries. If you put a module on a class path, you can do anything with it. Only if you put a module on the module path will it be enforced. That is not helpful. Cool. So moving on, we got small heroes. My beautiful AI-generated hero character. So just saying, Google Gemini wouldn't allow me to generate anything with the Duke character from Java. It said that that was a restricted person. Who knows why? First of all, you've probably all seen it today. We've got public static void main. We've written this for so long in Java that it's probably just muscle memory. Of course, we can just focus on the bit that actually matters, remove it, hooray, we get a green tick, it's good. We should start using that. If you want to keep the static in there, that's fine, but there's really no point in keeping the whole shebang going now. We might as well move across to the new feature there. What about multi-line strings? Well, that just gets a straightforward green tick, right? I mean, there's nothing really to talk about with multi-line strings, right? Well, just little warning. Because we have multi-line strings, you might be tempted to write SQL statements in there, and you might be tempted to just do a quick replace on it. But of course, that's an injection attack. So multi-line strings are great. Let's not do them down, but just be aware when you're using them that every new feature has some potential downside to it, and that's the potential downside for that one. Unnamed variables. So this is actually great. So if you look at those two lines of code, you've often probably written something like catch exception ignored, or where we're reducing something, A and B, but we just want A, we just want to choose the first one, right? So now we can actually get the compiler to check that for us. So we can just put an underline in there to say this variable is unused, it's not going to be used, you can't refer to it. And that's great, that gets the green tick. But my feeling is that probably you still end up having to use some kind of comment to kind of explain why it's unused, or perhaps it shouldn't be unused in the first place, perhaps the exception should be being used. So there's a little bit of a downside there, perhaps with the needing for a comment. Module imports. So as part of the main method change, you can actually import a whole module. So you could now in your code write import module java.base in Java 25. And that will import all the classes from the whole of the Java base module. So it'll import lists and maps and input streams and output streams and all the rest of the shebang. So you can get rid of all of that lot on the right with what's on the left. So are we all going to jump up and down and adopt this? I don't think so. Ultimately, I think ingrained in Java developers' memory is this idea that wildcard imports are pretty much frowned upon. So should we just import module Java base and not any other modules? That would require tooling changes, it would require changes in IDEs, it would require changes in check style. I don't think it's going to happen. So I think fundamentally, module imports are something which is interesting for newcomers, but probably not something that should see widespread adoption. Markdown docs, perhaps more interesting. So you can write Java doc in HTML, you can write Java doc in Markdown now. Which of those two is easier to read? I don't think there's really any doubt about which of the two of those is easier to read. The question is it worth switching? Now, if you can get some tooling that's going to switch it for you across a whole code base in a single go, maybe. I don't think such tooling exists at the moment. There's little you can do one at a time in IntelliJ, for example. So I think the best practice with these smaller changes is keep up to date with them, see what they are, but think before just adopting them. Just because something new and fancy has come out, it's not a good reason to go out there and say, I must adopt this. Maybe the feature wasn't targeted at your kind of code base, maybe it's just not suitable, but the right small change can make a big difference to how your code looks and can be really beneficial. Cool. So immutability. So back in my talk in 2016, I did briefly mention immutability, but I probably should have made a bigger deal of it then. Fundamentally, it is the linchpin of modern Java. Now, I know that an awful lot of people still write beans which are mutable and with setters and so on. But I want to emphasize that immutability is the direction of travel and really should be front and center of your thoughts. Ultimately, it's just mutable things will change beneath your feet. You don't know what's happening. The whole point of it being mutable is that it changes at some point in the future. If something's immutable, it's locked down. It doesn't change. So the best practice here is clearly to favor immutability. Final classes, final fields, keep all the mutability you can, ideally within the source file. So if you've got a source file and you need to do something mutable, keep the mutability within that file. And maybe really knock people on the head in code reviewing by naming the parameters and the variables mutable something. It should be unusual. It shouldn't be the norm. If you can do that, you'll end up with code that is simpler and better to use in multi-threading. Do watch out for immutable collections. So Guava has immutable collections. There's also list.of, set.of, map.of in the JDK. Collection.unmodifiable, it's okay, not quite as good. What we need to do is trust that immutable means immutable. So immutable collection array or bean within an immutable object is a backdoor, and we don't want that. We definitely don't want that. It's all great, right? So here's an example we've got. We're creating map.of with some phone codes, GB, France, Belgium. We're checking that the toString matches. All good, right? Wrong. That is a flaky test. Because every single time the JDK runs, it resets the randomness seed within map.of and set.of. So they will have a different order every time that code runs. So you've got to be very careful about using map.of and set.of and make sure that you're not reliant on the order of the variable or the order of the content of the map or the set. Hopefully, we'll get something better in the JDK, maybe sequence map.of or sequence set.of, which will allow us to express what we really want, which is an ordered map or an ordered set. Just a brief mention here for composition. Immutable classes, you generally shouldn't be doing hierarchies of them. You shouldn't be having superclasses and subclasses, so you should be preferring composition. This is something that goes back to Java, Josh Boxbrook. It goes back ages. Ultimately, yes, you want composition, not inheritance. Immutable classes shouldn't have composition. Optional and null, we got there. I quite like the one on the right representing null. Effectively, you're going to get your fingers covered in blood going into that lovely pot there. So the question really is, it's still controversial in many ways, is optional better than just using null? Null needs discipline. You get your value back, you find foo, you've got to check that it's null, you've got to know that it's null, and nothing helps you to do so. The type system, if you use optional, forces you to do that, and that's why optional on return types makes sense, because it forces you to address the issue. So the basic level of optional is basically, you could just use is present or is empty, but you shouldn't do. There are better ways of doing that. You should use a functional method. One problem you may face with this is you may face something like where you need to use return within the block of an if statement where you're dealing with an optional. One way around that is to write some kind of utility like this, which is to say in optional. So you can basically loop around an optional, because an optional is ultimately just a list of 0 or 1 things. So you can loop around it, and it'll only go into the body of the loop if the optional variable is present. Nice, easy method you could write. So the best practice, and this is really a reiteration from what I said 9 years ago, is use optional instead of null on public return types. It makes a big difference in your API and its understandability, and reduces the number of null pointers or exceptions you get a heck of a lot. Don't use it as a parameter type, don't use it as a field, avoid is present and is empty. And I think this is the most widely accepted approach. It's too much hassle to use parameters, it's too much overhead to be a field, certainly. What I did suggest a while ago was the idea of, if you have a getter that is optional, what should that return? Unfortunately, our frameworks don't allow that return an optional object. They expect it to be null. So unfortunately, it's really quite hard to justify saying that the best practice for getters is to return an optional object, but I wish it was. So I wanted to just do advanced here. So if you're using optional, you really should be learning the API, and you should know it as well as the streams API, because ultimately it kind of is the streams API. A stream is a stream over a whole set of things. An optional is just 0 or 1, and you can stream over 0 or 1 things in exactly the same way. So here's a classic example I think makes something quite readable. You find it from a new database, or you find it from an old database, and you do some mapping and some filtering or else, and that's all on optional objects, not a stream, on optional objects. And it reads really nicely. Future. It's worth mentioning this now because at some point in the future we may well see question marks and exclamation marks, bangs, to represent nullable and non-nullable. Now if we do that, you might be tempted to put that method find person now returning a person question mark. But let's see what happens. Maybe it'll err, maybe it won't. But remember, this was our example that we had, which looks really nice and easy to understand. And if you replace this with person question mark, this is what you get. Before and after. Now, I challenge you to say that that second one is better. I don't think it's better. So I think the argument is we should still use optional for return types, even if we have question marks and bangs as our emotional types. And that's what I say is my best practice. Ignore the null restricted types for the moment. Focus on optional return types because it's better. Cool. var. Oh, good. So yeah, I think we probably all know what var is. Local variable, declared the type, it only affects things, right? Ultimately, that's the code we all write, It's a bit hard to pull out what it is. What's the important bits here? The important bits are the path and the lines. So we just get rid of them, right? Nothing's really changed. It's still actually the same types in the code, in the byte code. Nothing's really changed. But people resist this. I'm not quite sure why. So most other languages actually support this. It's a very popular request. If you actually go back and look at the OpenJDK mailing list, it was a really popular thing to happen. There was loads of engagement about it, and yet it's still controversial. Oh, it's less readable, or I've lost my types, or now I've got to add a generic info where I didn't have generic info before. Yeah. Well, what about this Java? That's normal Java, right? Well, it kind of isn't, is it? If you look at those lambdas at the bottom, we don't actually put in the strings there, do we? We take them out and we we do type inference on them, right? So why can I have type inference in lambdas, but I can't have type inference on my local variables? Is there really a difference? Makes you think. I think the best practice is to use var. I think the best practice is when you go all in on this and you don't mess around, but you do need to make sure that you name your variables well. It does work well in practice. I've used it. It's fine. It does simplify PRs because you've got fewer imports, less churn. But you must use good variable names. You want to describe the data and not the type. It's not just a list of customers, it's a list of something else, right? A list of something that has meaning. I would recommend using opt as a suffix if you're going to use var with optionals. Switch. So good old switch. It got lots of upgrades over this period. There's statement switches and there's expression switches. We've got label ones and we've got arrow ones, fall through versus non-fall through, exhaustive versus non-exhaustive. Let's have a look at it, shall we? That's our old switch. That's our old friend. We know what it does. We've got some labels, Monday colon, Tuesday colon. Obviously, if it's Wednesday, it's just going to drop out the bottom. It's going to just come out. That's fine. And yeah, we've got the breaks. Well, we obviously need breaks, otherwise things are going to go wrong, right? It's going to fall through. So what got added was this, 3 more kinds of switch. So there's label switches that are expressions. That's the top right. And then there's arrow switches in both statement and expression form. So each of them has got their own subtleties. So obviously in the top right, you've got yield, which has to be used as a mechanism for returning the value in the expression. In the bottom form, we've got arrows, which have a bit more control. So let's drill down a little bit further. What happens if you forget your break or you forget your yield? You get fall through. It falls on. So in the example here, you get Monday will fall through to Tuesday. So it'll do all the things for Monday followed by all the things for Tuesday. Probably not what you want. So those top kinds, the label kinds, they fall through, and the bottom kinds don't fall through. Now I would argue that in pretty much most business applications, like 99.9% of business applications, you don't want fall through. It's just confusing. So kind of ruling out the top 2, right? The ones on the right, expressions. Well, if you have an expression in Java, it needs to return a result. It needs to return a value. So that's why we've got this default on the right-hand side. There needs to be something to make sure that, well, not only Monday and Tuesday are covered, but Wednesday to Sunday are covered as well. Some value has to get returned. So that's called exhaustiveness. So obviously the column on the right, they're exhaustive. They're expressions. They have to return a value. So obviously, the ones on the left are not exhaustive. Right? Wrong. Now you have to look at your shock and horror faces and when you realize that actually there's not 4 different kinds of switch, there's 6 different kinds of switch. Because on the left, statement switches are split up and it depends. So if you have case null in there or you have patterns in there, then it turns out they are exhaustive. And if you don't, they're not exhaustive. Nice and easy to follow, right? So let me simplify it for you. Do that. Totally ignore the labeled forms, i.e. there really wasn't any reason to add the one on the top right at all to Java. That could have just been left out. The one on the top, the one on the bottom left, that should have been exhaustive, and then the bottom left box would have been simpler. But there we go, that's not what we got. So you are responsible, in your best practice, always try and use the arrow expression form. So in other words, always try and return a value from your switch statements, because that is by far the safest approach. If you have to use a statement with switch, you are responsible for making sure that it's exhaustive. In other words, you are responsible for making sure that Monday to Sunday are all covered. And case null, well, I mean, it's useful, but I mean, try not to have null in the first place would be my best practice. Patterns. So we got this code. We've had this code for many years. We check, is it an instance of a JSON object? We cast it, and then we assign it to a local variable, and then we use it. All good, right? But it is boring, it is error prone, and this is why we moved on. So ultimately, what we've done is we've added in this ability to put the JSON object up there and get rid of that line. And it's a lot quicker and a lot shorter. And that's a tick. That is a good move. We should all be doing that, and all should be using that. Can equals be fixed? Well, ultimately, equals is exactly the same instance object. We can put the other up there. We can move the line up. But actually, that instance of my class other is a Boolean expression, so we can simplify that further. And when you write an equals method, it should probably look like that now. That should be the standard pattern for our equals methods. So the instance of improvements, they're all excellent. I think it's actually so good you should probably go around your code base, find the instance ofs, and replace them. It does make code a lot easier. So what about switch? Well, yes, switch has these patterns in. You can check, and you can do a case, and you get back a typed object on the right. So again, that's all good. No downsides, so we can move on, right? At this point, I want to pause a bit, because I want to just sidestep into records, because I think we need to cover records before we go back and look at switch again. And patterns, which is the more important bit. So, do your Java beans extend Java AWT component? Do they? Do you use casts with your Java beans? Instance of, or checked exceptions? AWT style expense handling? Your beans are not Java beans, right? The reality is that the specification of Java beans is ancient. It's from 1997. It's about software components that can be manipulated visually. It talks about arrays. It does not talk about lists and maps. There's all sorts of special classes around bean info and so on. But what we generally use day in, day out, they're not Java beans. They're beans. At least that's the best term we've got for them. And they're really an informal specification. There's nothing formal about it at all. So we took the get, is, and set methods from the original Java beans, and we threw everything else away. What it does mean is that every individual framework has its own reader and writer. And so they might all be subtly different. And that is a bit of a dodgy framework for massive Java apps. So we've kind of crossed out our Java beans. We've got beans instead. Well, that's good. OK, cool. But if you actually look at a bean, and you look at the important bits of a bean in red, well, that's what a record does. It just takes the important bits of the bean, pulls them out, and we got a nice record, right? Hooray! Let's go party, let's go party. So records are there immutable. It's just a group of fields with a class name, generated fields, generated equals hashcode toString, compact constructors. The getters aren't prefixed by get, so it's a different naming convention. So think about arrays with records. So records are immutable. Arrays, you can't lock arrays down to be immutable. So arrays do not mix well with records. So definitely avoid having any arrays within records. It's not a good idea. If you do, you've got to override a getter and a equals and a hashcode and a toString. Well, what's the point of having a record if you've got to override all of those things? Same idea with mutable fields. So when you're dealing with records, it's not just the fact that the record is immutable. You've got to make sure that the fields within it are immutable as well. So yeah, do that and prefer basic types. So really you want your record to be holding a string or a local date or a UUID, the basic types. Do validate them. Make sure that they're a solid, reliable state that you can rely on. And yeah, do think about whether that toString method will expose any private data. Does any GDB data leak out into logging? You might not be quite what you want. So great. We've got records, we've got beans. Just want to have a little look at that gap there. So here's a brief, picky summary of what beans and records have. So we've got records with one naming convention, beans with another naming convention, immutable with some ticks, beans with some ticks. There's not much overlap between those two things. And I think that's the point here. is that these two things are very different language features. Records don't replace beans. You have to adopt them in a different way. So classes, they're about encapsulating state. Beans are about exposing particular pieces of the state. But records are totally transparent. It's like me running around this room totally naked. Right? A record is exposing everything. You don't want that. So this is cliff edge, a bean record cliff edge. So records and beans, they are different things. Records have this lovely syntax. It's almost this bit too attractive in some ways because everybody thinks, well, I want the short syntax, so I must go and get it. But they're not flexible. And if you reach the semantic limits of what a record can contain, there are some cliff edge problems here. Frameworks may well operate differently on a record and a non-record because the getter styles are different, because the code path is likely to be very different inside the frameworks. So if you're going to use records, you need to be disciplined about it. You need to make sure that you're going to go all in on records and actually accept those limitations, or you need to have some kind of strategy for saying, well, this is what records should be and these ones are not. But records are great. Just be aware of those limitations. Think first before you just dive in, basically. So I put those in here. There's a third column now for generated. If you go down the route of generating your beans, you can perhaps close that gap between records and beans and come up with something that's better. Now, generated tools, obviously, we've got Immutables, we've got Lombok, there's my own Jada Beans. There's a number of tools out there that can generate beans. And it can be a better strategy than just handwriting them or getting your IDE to generate them. So yeah, I would argue that it's a best practice to generate beans. Don't write them by hand. Cool, so back to patterns. So we talked about instance of and switch, but we didn't really go into details of what it is. So if you just look at the syntax is nice. It's shorter, it's better, but we didn't really dig down into why it's better. The fundamental change here is pattern matching. And I'd argue that it's not enough just to know the basic high-level changes to instance of and switch. We want to dig down a bit further and understand what a pattern is and what pattern matching is, because it's a big change. So if we look at what classic instance of was doing, it was doing three things. It was testing something, and if that was true, it was extracting information from the target, in this case just using a cast, and then it was binding that to a new local variable. So it's doing three specific distinct things. And what the pattern does is it unites those three things in a fused operation. So all patterns have the capability to test something, extract something, and bind local variables. They don't have to bind any local variables, but they should generally be a fuse of those things. So the syntax for pattern matching does vary, and this is perhaps what catches people out sometimes. So we looked at our instance of what we had earlier, and it was instance of person P or switch target case person P. It perhaps wasn't obvious that the person P isn't just a bit of syntax, it's a pattern. So the more underlying feature here is you've got instance of pattern and case pattern. Now, if the JDK and the Java language people have written this as the syntax, it perhaps might have been more obvious to grasp that actually the thing coming next is a pattern. If we'd had a syntax like matches pattern. But no, that isn't the syntax we got. We've got this. So you have to be aware that you have to know where the patterns are, or I suppose you just don't worry about it. But we are likely to see more patterns over time. So this is some of the directions that Oracle's talking about as to where they'd like to see patterns in the future, whether with this syntax or not is an open question, of course. The ability to create a local variable using a pattern. In other words, the ability to extract values out and create multiple local variables from a return type, perhaps. or a for each loop. So you could loop over a map entry. So you could get both the key and the value out of a map when you're looping over it, which would be nice. Or to catch a pattern. All of these are places in the language where patterns could be added. So what we've seen so far is a type pattern, which is just the string str. So is it an instance of string? If so, cast it, that's the extraction phase, and bind it to the local variable. Great. We know what type patterns are. We've seen a lot of them. But there's another type of pattern, which is a record pattern. So the record pattern you can use with any record. It tests, is the target a record? And if so, extract and bind the fields of the record. And that's great. So we can now take any of our records and we can get the stuff out from inside the record in one step. That's a good thing. But actually, what we saw before, the inside parts of the record pattern aren't actually part of the record pattern because patterns nest. So where you've got string name and number age, those are type patterns nested within a record pattern. So patterns nest. That's why I say patterns are quite a fundamental concept that you have to try and get your head around. They're a new thing in the JVM generally, in the new Java language generally. But in fact, that previous slide was slightly wrong because the thing inside a record is not a type pattern. It can be any pattern. So you can actually have a record pattern within a record pattern. Well, within a record pattern within a record pattern. They nest in any way necessary to express the structure that you're being given. So here, I've got a person which holds an address, and I can pull out not only the person's name, but I can also pull out the line and the city from the address. So it's quite expressive in terms of what can be pulled out, but it's all nested patterns. And as I said, there's more types of pattern out there. So the third type of pattern we actually have today in Java 25 is the match all pattern. So basically it's a pattern that matches anything. So you don't have to worry about it. So let's say I only wanted the city from my previous example. I don't need to have the name or I don't need to have the line. I just use the underscore to represent the fact I don't care about those particular parts of the pattern. And that's quite useful. Definitely something you should use if you don't need a variable. Now what about record patterns and null? Null is always the sharp edge that's going to break your finger. So a type pattern is effectively an instance object, right? Not quite. Type patterns inside records can match null. So here we've got a person object that is a string name and a number age. But if we specify string name integer age, then that age will not be null. But if we specify number age, it might be null. Now, why is that? Well, ultimately, what the compiler is doing, you have to think about it in terms of what the compiler is thinking. When it looks at number and number, so it can see the record is defined to use a number, and it can see your bottom case statement uses number. So it goes, well, that's the same type, so I don't need to perform the if step of pattern matching. I don't need to perform the test. I know they're the same type, so I can always match it. Whereas with integer, the only way it can know it is an integer is if it dynamically tests that at runtime. And if it's dynamically testing it at runtime, it has to be not null. Now, most of you probably not thought about the subtleties of that, but it is quite subtle and it is quite complicated. So there's a way in which I think you can make this code easier to follow and easier to read, but I know not everybody agrees. If you use var to represent those places where the type is the same as the record, you're highlighting the places where the type is different. So basically, by putting var name, I'm saying whatever the record is defined as, I want to accept. In the age, whatever the record defines as, I'm taking it. But if I definitely want an integer, I'm specifying that. And that's much clearer for you to read. So I would argue the best practice, which is perhaps the most controversial of these, is that you should use var inside record patterns as much as possible because it highlights what's going on more clearly. What about the future of patterns? Well, there are current patterns. Obviously, we've got type, record, and match all. There's future ones to come. We might get array patterns. We might get user-defined patterns. I haven't got a crystal ball. We'll see what happens. But yeah, patterns and pattern matching, they are a key change from the last 10 years. And it really is important to understand more than just the syntax changes. If you can get your head around what a pattern is and how it works and how it nests and how it interacts with null, that is a good thing to have learned. Sealed types, I can only mention this briefly, but think of record as being and something. A person is a name and an address. But what if there are two different kinds of address? Well, that's what sealed types represents. So here I'm saying that an address is either a street address or a military address, and no other kinds of address are allowed. So it's the equivalent of or, which is useful because I've now told the compiler more information. I've told the compiler that there can't be any more subtypes of address, and that then allows it in pattern matching to be more exhaustive. If you remember our switch statements in exhaustive, it allows us to do more exhaustive stuff. There we go. So now we know there's a person with a street address or there's a person with a military address, and that's covered all the different kinds of people that there are, which is great. So if your data does have constrained choices, then do preferred seal hierarchies because it is quite a powerful tool. But I would suggest, at least until you've really got your head around it, just keep it simple, use an interface at the root, and don't go down the route of complicated subtypes like non-sealed and other things. If you need them, great. If you're going to learn them, great. But keep it simple. Keep it just for or. So briefly, the thing that sort of pulls all these things together is data-oriented programming. Now, data-oriented programming is an entire talk in its own right. So this is a very brief summary. But going back to our hierarchy here of the timeline of Java, there was kind of an era of objects. When I started off in Java, you got sent on object-oriented programming courses. That was an important part of being a Java programmer. You wouldn't get sent on those courses today. That kind of finished around the Java 8 period. Everybody started talking about functional programming with other languages coming out, and that was all the exciting rage. And so there was a functional era. And if you look back, why are we doing a best practices talk now? I kind of feel like this has been the data era of Java. A whole set of language features that are built up to create this story around data. So why now and not the future? Because I think, hopefully, fingers crossed, before too long, we'll move into the values era, where we'll see a lot of features being added that are more focused on value types and Valhalla. So I think it's a good point. How much do these worlds overlap? Not that much. So the object-oriented world is mostly about mutable things, inheritance, encapsulation, polymorphism. Data is about immutable, records, enums, transparent data. But a lot of people live in this world in the middle. Being world. Sort of mutable, but we use composition, sort of classes, but we sort of use functions and methods. It's a bit wishy-washy, vaguey. I would encourage you, if you can, to try and get yourself more across to the data-oriented world, get more across to the immutable side, and lock that down if you can. Ultimately, it is a clearer approach to design, and it works well because these modern systems tend to be smaller. So just briefly summarizing, here's a typical system, a client talking to a database, a CRUD application fundamentally. Where's a good place for record? Well, JSON to a record is a classic way on the way in, and record to a database is a classic way on the way out. Those are just data representations being sent to different places. They don't need to be mutable. They're not going to change over time. It's better if they don't change over time. So there's plenty of good places where records can live, but you have to commit to it. So do focus on the data. That's what our applications are fundamentally about. Validate at the boundaries, make sure data is valid, and then you're not getting bad data in. And yeah, just use simple types. So local date, string, int. Keep the types simple. Enums are a good example. And that's kind of the summary of how these 4 language features work together to enable data-oriented programming. Records allow you to express and, seal allows you to express or, patterns allow you to operate on those things, and enums allows you to validate just one thing. As I say, data-oriented programming really is a whole talk in its own right. But that is the direction of travel we've had over the last period of time since Java 8. But yeah, keep the data separate, keep it immutable, use the right tools. And it's a system choice. You need to buy into it from the start. You need to actually focus on doing it that way. So we can put our feet up, finally. I've given you 21 best practices. There's actually 22, but one of them was really a repeat from last time, so I didn't count it. I've only focused on the language. There's plenty of other good stuff in there. So gatherers, if you need gatherers, make use of them. Yeah, they're a fantastic feature that allows you to do way more things with Stream than you've ever done before. Virtual threads, foreign function APIs, you probably won't use them in a typical day-to-day application, but if you do, they're great. They're going to make life a whole lot easier. As I said here, fundamentally, I've tried to express a rationale. Why should we go? Why should we use these features? How are these features best used? My top tips: invest the time to learn patterns and pattern matching properly. Don't just think of it as a nice short syntax. It's worth learning properly. Use optional like stream. If you're just using isPresent or isEmpty, you're missing the point of the feature. It needs to be used with the actual methods, not just as an alternative to null. And do keep up with the latest version of Java. Cool. So thank you very much, and see you soon. So we've got a very large room, so I'm not going to take questions because it'll be chaos. But if you do want to chat to me, do just come down. Thanks.